On the southern edge of Memphis, an artificial intelligence company needed more power than the local grid could deliver on its schedule, so the power plant arrived on trucks. Rows of mobile gas turbines were installed across the Tennessee state line in South Haven, Mississippi. High-voltage lines carried their electricity back toward a data center called Colossus 2. In April 2026, a federal lawsuit described 27 turbines at that site. Mississippi had separately approved a future configuration of 41 permanent machines. Then, on July 14th, Reuters reported that communications between regulators and company representatives showed 59 turbines installed for the project, at least 57 of them in South Haven. Those are not three revisions of one simple number. They describe different dates, different equipment, and different legal categories. xAI and Mississippi regulators say the mobile units did not require the federal air permit demanded by the plaintiffs. The Justice Department has asked the court to dismiss the lawsuit. The plaintiffs say the fleet is a major source of pollution that was built without mandatory review. The dispute is still active, but the physical system is already here. A private bank of turbines, large enough to resemble a utility power station, built to keep an AI supercomputer moving at a speed the ordinary grid could not match. xAI says it paid for its infrastructure. That answer matters. It also leaves a harder question. When a company can build computing capacity in months, but power lines, permits, and public oversight move in years, who pays for the difference? The story began inside an abandoned appliance factory. Electrolux had closed its Memphis plant, leaving a large industrial building beside existing water, gas, and electrical infrastructure. In March 2024, an xAI affiliate began leasing the site. By June, local leaders were announcing a new artificial intelligence project. xAI called it Colossus. The company says it was told the build would take 24 months. It says the first system was completed in 4. That speed was possible because the project did not begin with raw land. The factory shell already existed. A water main and gas main crossed the industrial park. An old substation stood beside the building. Crews could fill the floor with racks, cooling equipment, power conditioning, and networking while the permanent utility system was still being expanded. The electrical system does not live on that clock. A utility must study whether a new load will overload a line, destabilize a substation, or leave existing customers exposed during a peak. Equipment has to be ordered, rights of way have to be secured, protection systems have to be coordinated. The grid has to survive the first day of the new load and the worst day after it. Colossus compressed the computer schedule. It could not compress every piece of infrastructure around it. An AI data center looks quiet from outside because most of the motion is hidden. Inside, electricity passes through substations, switchgear, transformers, backup systems, and power supplies before it reaches the processors. The chips perform calculations. Almost all of the electrical energy becomes heat. That heat has to leave. Fans move air, pumps move water or coolant. Chillers and heat exchangers carry energy out of the server halls. Networking, storage, lighting, controls, and security add more demand around the computers. Power is the rate of electricity use at one moment. Energy is that rate sustained over time. The grid must be built for a credible peak and the loss of a line or transformer. AI adds synchronized changes as groups of processors begin or end work together. Batteries, ramp limits, and demand response help that electronic load behave like something the wider system can absorb. At the beginning, Memphis Light, Gas, and Water could use the old Electrolux substation. The utility said a few new circuit breakers could raise its capacity to 50 megawatts. To reach 150 megawatts, xAI needed a new substation, improvements to a 161 kilovolt transmission line, approval from the Tennessee Valley Authority, and an agreement to reduce consumption when the wider system was stressed. By MLGW's 2025 update, the Paul Lowry Road campus was receiving 150 megawatts from the grid, 8 from an existing substation and 142 from the new one. xAI wanted another 150. That is the useful way to understand the project. Not as one giant switch, but as a sequence of power layers arriving behind the processors. Old infrastructure, new grid capacity, batteries, and gas turbines filling the gaps. The direct utility bill is the strongest part of xAI's case. MLGW says the customer paid for the transmission upgrades and the new substation. The utility's first public summary identified $1.7 million of work on the high-voltage line. xAI later said the complete 150 megawatt substation cost $35 million and that it would spend another $20 million on a second one. The company pays the prevailing industrial electricity rate. Its agreement with MLGW and TVA requires curtailment when demand is high. xAI also says it has installed or ordered more than 240 batteries so the first campus can come off the grid during an emergency or a peak. The utility studied the load and attached conditions designed to protect existing customers. It also projected added payments to the city and more than 300 jobs, although those totals remain forecasts. But utility cost is only one kind of cost. A customer can pay for copper, transformers, and circuit breakers. That does not automatically price the air around a generator, the time of public regulators, the risk of a legal shortcut, or the confidence of a neighborhood that learned about a major industrial project after work was moving. The first Colossus site would make that distinction visible. The old substation could not power the complete first cluster on day one. xAI used gas turbines while the grid connection grew. The federal complaint filed by the NAACP and its Mississippi Conference says 16 turbines, with roughly 105 megawatts of combined capacity, were at Colossus 1 by August 2024. It alleges that the number rose to 35 by the end of March 2025, with more than 400 megawatts of capacity installed. Those are allegations in pending litigation, not findings by a judge. What is settled is that xAI later obtained a Shelby County permit for a different configuration of 15 turbines. The company's own timeline records that permit in July 2025. It says the permitted plant would be exceptionally clean for its type. Opponents ask what happened before the permit and whether moving a turbine before a year had passed really made a utility-scale fleet temporary. The first site therefore created a model. Compute capacity first, mobile generation beside it, permanent grid capacity later. When xAI expanded to Colossus 2, the company repeated the speed. The geography changed. Colossus 2 occupies another industrial building at 5,420 Tulane Road, close to the Mississippi border. In July 2025, MLGW said it supplied that property with only about half a megawatt of ordinary service. The utility was explicit. It was not powering the Colossus 2 supercomputer. The larger power source appeared about a mile away in South Haven. The data center remained in Tennessee. Most of the turbines, gas infrastructure, and generation site sat in Mississippi. New lines connected the two. From an engineering perspective, the state line is invisible. Electrons do not stop at a border. A transmission conductor sees voltage, current, impedance, and protection settings. Air moves just as freely. From a regulatory perspective, the line matters. Shelby County handles important air permitting functions on the Tennessee side. Mississippi's Department of Environmental Quality administers the program in South Haven. Federal standards sit above both. A lawsuit filed by residents and a civil rights organization can add another enforcement path. That division created a strange physical map. The computing load, many of the promised jobs, and much of the tax story were centered in Memphis. The largest new combustion source was placed beside South Haven. Communities on both sides could experience noise or emissions, while different governments made the key decisions. The faster the project expanded, the more important those boundaries became. A gas turbine is simple in outline. Air enters a compressor. The machine squeezes it to a much higher pressure. Fuel mixes with that compressed air and burns. Hot gas expands through turbine blades, spinning the shaft that drives both the compressor and an electrical generator. The machine can start far faster than a large conventional power plant. Modular units can be delivered, connected, and repeated. That makes them valuable when a data center developer needs hundreds of megawatts before a permanent grid connection is available. It also makes a temporary fleet capable of becoming a power station one module at a time. Most mobile units in this role operate as simple cycle machines. Their hot exhaust leaves after one pass. A combined cycle station captures that heat to produce more electricity, but needs permanent equipment and longer construction. Simple cycle trades efficiency for speed. That can be rational for an emergency. If the bridge runs constantly, fuel use and emissions per unit matter much more. Dozens of modules also require coordinated gas pressure, maintenance, controls, and electrical protection. Fast assembly does not remove utility engineering. Dozens of machines need gas supply, controls, transformers, switchgear, maintenance access, and high voltage lines. Their sound and exhaust combine. Their schedule determines how much fuel is burned. Some large turbines use controls such as selective catalytic reduction to reduce nitrogen oxides. Permit conditions can set operating limits, monitoring requirements, testing, and reporting. Without an applicable permit, plaintiffs argue, the public loses those protections before operation begins. xAI and Mississippi take the opposite legal position for the mobile equipment. The units qualify as temporary sources and do not require the federal permit at issue. EPA revised its turbine standards in January 2026 and created a subcategory for temporary applications. But that sentence alone does not decide the lawsuit. The definition, installation history, location, operating facts, and relationship among the units all matter. That is why the numbers cannot be separated from the categories. There are 4 numbers that define this story. 15 is the number of turbines permitted at the first Colossus site in Memphis in July 2025. 27 is the number of temporary units described at the South Haven site when the federal complaint was filed in April 2026. 41 is the number in a separate Mississippi permit for a permanent plant. Those machines were proposed as a controlled configuration. Opponents appealed the approval, arguing that the modeling and pollution protections were inadequate. 59 is the installed count Reuters reported for the Colossus 2 project in July 2026 after reviewing communications between regulators and company representatives. The report said at least 57 were at South Haven and that the company had previously acknowledged 27. A permit for 41 future machines does not automatically cover 59 different temporary ones. The distinction is central to the case. Reuters described the equipment as installed. That does not prove every turbine ran continuously. The article also reported potential emissions using equipment information and government data. Potential to emit analysis is designed to ask what a source could release under defined operating assumptions. It is not the same thing as a monitor measuring every exhaust stack for a year. The safest conclusion is also the most striking. Before the dispute over the 27-unit fleet had been resolved, the documented physical footprint had grown much larger. The AI build kept moving while the rules were being argued behind it. Burning natural gas can look clean because it produces less visible soot than coal and often less carbon dioxide per unit of electricity. It is not emission-free. At turbine temperatures, nitrogen and oxygen in the air react to form nitrogen oxides. Those gases help create ground-level ozone, the main ingredient in smog. Ozone can inflame airways and make asthma and other respiratory conditions worse. Incomplete combustion produces carbon monoxide. Turbine exhaust can also contain formaldehyde and fine particles. Formaldehyde is a hazardous air pollutant. Fine particles can travel deep into the lungs. The amount depends on the turbine, controls, fuel, load, maintenance, and operating time. The April complaint estimated that the 27 South Haven turbines had the potential to emit more than 1,700 tons of nitrogen oxides in a year. Reuters later estimated that 30 of the units it identified could emit roughly 2,500 tons of nitrogen oxides, 4,000 tons of carbon monoxide, and 22 tons of formaldehyde annually. Those are modeled annual figures, not a claim that those exact masses have already been measured in neighborhood air. That difference is why permits often require testing and records. A stack test measures performance under defined operating conditions. Continuous or periodic monitors show whether controls remain effective. Fuel and operating hour logs turn a rated machine into an annual inventory. Without those records, the public argument can get trapped between a theoretical maximum that may overstate actual operation and a promise of low emissions that cannot be checked independently. That caution should not make the mechanism disappear. Dozens of turbines placed close together can form a major industrial source. Permit review exists to decide which controls, limits, offsets, monitors, and records are required before the public has to infer operation from aircraft, heat images, or correspondence. The fight is therefore not only about one number on one stack. It is about whether speed changed the order of decisions, build first, count later, and litigate the permits after the power was already important to the computers. South Memphis was industrial long before artificial intelligence arrived. The Colossus 1 site sits near Boxtown, a historically black community. Refineries, steel, power generation, wastewater facilities, highways, and freight infrastructure already shape the area. Across the border, neighborhoods in South Haven sit close to the newer turbine field. Residents and local groups have described noise, poor communication, and fear that another large source was added to a place already carrying more than its share of pollution. Those concerns do not prove that xAI caused a particular illness. They do explain why a permit argument is not an abstract dispute about paperwork. Reuters compared government health and census data around the project. Its analysis found predominantly black populations near the two sites and elevated estimated rates of lung disease. The reporting did not say the company deliberately selected those communities because of race. The fairness question is narrower and harder. Who received early information? Who had time to review the emissions model? Which public meeting was close enough to attend? Which state had authority when the power plant and the computer were separated by a line on a map? xAI says it has invested in schools, road cleanup, local contractors, and community organizations while creating jobs and tax revenue. Those benefits belong in the record. They do not purchase silence. A community can value jobs and still demand monitors. It can support industrial reuse and still question a turbine count. It can want Memphis to lead in AI without accepting that speed should become an exemption. In June 2026, the dispute moved beyond Mississippi. The United States Justice Department asked to intervene and dismiss the citizen lawsuit. Its argument was unusually direct. Mississippi had determined that the disputed temporary units did not require the permits sought by the plaintiffs. The department said an injunction could shut off critical power during an energy emergency, impede AI development, and harm national security because federal defense work uses the technology. The plaintiffs see that position as an attempt to remove a Clean Air Act enforcement tool precisely when regulators have allowed a major source to operate. The court must decide the legal questions. The infrastructure lesson is already visible. A private data center became important enough that the federal government described its local power supply as a national security interest. That changes the balance of leverage. A utility can require curtailment. A regulator can demand controls. A community can sue. But once the computers are linked to defense, economic competition, and national AI policy, any interruption can be framed as a threat far larger than the neighborhood around the stacks. The company that built fastest may also create the strongest argument against stopping later. If review happens before construction, conditions shape the plant. If review happens after the plant is powering a nationally important system, enforcement has to confront the cost of turning it off. Speed is no longer just a business advantage. It becomes part of the legal architecture. Power is only half of the support system. The heat leaving the processors has to go somewhere. At the first site, MLGW said an existing water main could supply up to 1 million gallons per day without reducing availability to other customers. The larger solution was supposed to use wastewater instead of drinking water aquifers. MLGW described a plant that would take treated discharge from the Maxon wastewater facility and produce 13 million gallons of recycled water per day. xAI, TVA, Nucor Steel, and other industrial users could use it for cooling, reducing demand on the Memphis sand aquifer. xAI says the project will cost well over $80 million. At full stated capacity, 13 million gallons per day equals about 4.745 billion gallons in a year. That is capacity, not a measured saving that has already occurred. The plant was delayed while xAI focused on stabilizing Colossus 2. The company later said work would resume with a target in early 2027. The sequence resembles the power story. The computers arrive first. Temporary or existing utility arrangements bridge the schedule. Permanent infrastructure follows. The correct question is not whether recycled water is good. It is. The question is what the campus uses while the recycling system is unfinished, who verifies the numbers, and whether the permanent solution arrives before the temporary one becomes normal. It is easy to tell this story as a company arriving, burning gas, and leaving everyone else with the damage. The record is more complicated. xAI reused a closed factory instead of abandoning it. It paid for identified grid upgrades and substations. It agreed to industrial rates and demand response. It invested in batteries that can remove load during a grid emergency. It committed money to water recycling, schools, community projects, and local contractors. MLGW says the first connection was designed not to reduce reliability for existing customers. More industrial sales can support the public utility and the city. The project has already created construction work and tax revenue. Memphis gains a place in a strategically important industry instead of watching the next technology cluster concentrate somewhere else. There is also a real engineering reason for local generation. The American grid was not built to connect gigawatt-scale electronic loads in a few months. Transformer supply, transmission construction, interconnection studies, and new generation take time. A company that waits for the perfect permanent system may lose the entire competitive window. Mobile turbines solve that problem with equipment that exists now. The fair case does not erase the permit question. It makes the question useful. If xAI paid every direct construction invoice, then this is not mainly a story about a hidden subsidy on an electric bill. It is a story about costs that invoices do not capture easily, pollution risk, enforcement capacity, public participation, and the precedent set when private speed becomes a reason to postpone public review. Economists call those effects externalities. A substation invoice has a customer name. The value of monitoring, public delay, or uncertainty about the air is harder to place on one ledger. That does not make the cost imaginary, it makes the payment mechanism political and regulatory. That is where who pays changes meaning. Colossus is not a normal building, and its power plant is not a normal backup generator. Together, they show what AI infrastructure looks like when the computer schedule becomes the master schedule. The racks arrive in months. The old factory becomes a supercomputer. A substation follows. Batteries fill one gap. Turbines fill another. A second data center appears. A power station grows across a border. Permits, appeals, and lawsuits chase the physical system after it is already difficult to interrupt. Some of that speed is impressive. It does not answer every public question. xAI can pay for a transformer. It can pay an industrial electricity rate. It can finance batteries, transmission work, and a recycling plant. Those commitments should be recognized and enforced. The company cannot purchase a private atmosphere. It cannot keep an exhaust plume on one parcel or one side of a state line. It cannot make public trust arrive on a truck after the turbines are running. The communities around Memphis and South Haven are not being asked only whether they support artificial intelligence. They are being asked whether the infrastructure needed for it can become essential before the ordinary rules have finished deciding what it is. 15 permitted turbines, 27 in a lawsuit, 41 in a separate permanent plan, 59 reported as installed for the second project. The important fact is not that one of those numbers must replace all the others. It is that the system kept growing while the meaning of the numbers remained contested. That is the hidden infrastructure race behind AI. Not simply who can build the largest computer, but who can make power arrive first, and who is left carrying the risk when it does.